Then other reactions that will be followed will be CH2Cl2 plus Cl2 will be CHCl3 plus HCl. Then CHCl3 plus Cl2 will be CCl4 plus HCl. So this is these are all halogenation. These are substitution reaction. Now, how this reaction takes place? Now we will discuss the mechanism. Now it is saying that this reaction goes by free radical mechanism. Okay, so what is free radical mechanism? That you can understand here. Here the first step of free radical mechanism is initiation. And what happens here in initiation, that suppose this is chlorine molecule, in presence of sunlight, or because with the help of this energy of photon, it undergoes homolytic fission. Bond breaks in the middle. So there will be chlorine free radical form. Chlorine free radicals are formed. Then after initiation, then it is followed by propagation. And what happens in propagation? It is this methane and this chlorine free radical it gives rise to here again homolytic fission of this bond take place, and methyl free radical and HCl is formed. And suppose in propagation, there are two steps actually takes place. So this is A, and in B step under propagation, what happens is this CH3 dot and another molecule of chlorine, then what happens is this again the homolytic fission takes place, and we get CH3Cl plus Cl dot. So see, we got the product, and this process gets repeated, and then this Cl dot will again act on another molecule of methane, and it will form CH3Cl, and again a free radical will be formed. This free radical will again act on another molecule of methane. Since this B process will always take place after A process, after A B, then after B again A, so that's why it is called propagation. And in the same way, you should try to account in this way. You should be able to account for the formation of this compound, in this way. You should try yourself. So initiation, then propagation, and the final step in free radical mechanism, it is termination. termination. In termination, what happens is the free radical disappear in the system. Okay, so termination, it can be like this methyl free radical. There will be a lot of methyl free radical system. They can combine to form your ethane. Or the termination can be your Cl dot plus Cl dot can give rise to Cl2. So all these are termination by which the free radical or the reactive species disappear. So this is about halogenation of alkane. It is substitution reaction, and it goes by free radical mechanism. Okay, now with a particular compound, with a particular alkane, the halogenation is found to be with fluorination is rate of fluorination is greater than chlorination. Chlorination in turn is greater than bromination, and bromination in turn is greater than iodination. So this is the order of halogenation, and iodination is very slow, very slow. Let us write iodination equation: CH4 plus I2 forms CH3I plus HI. In fact, iodination is so that it attains equilibrium. It attains equilibrium after some time, and so no further CH3I will be formed. Okay, we have a chapter in part 1, chemical equilibrium. Okay, that we will be doing afterwards. So iodination is slow, where and it reaches equilibrium. Now, this equilibrium means as a sort of thing that reaction has stopped. Once equilibrium is reached, we won't get any more CH3I. Now, if we use in this reaction a oxidizing agent, say HiO3. If we use in this reaction oxidizing agent, then the amount of CH3I can be made to increase. How it increases? Because this oxidizing agent, it oxidizes HI. It oxidizes HI to iodine and water. Iodine and water. So this HI gets removed, and this reaction goes more in the forward direction. This is we can understand from chemical equilibrium chapter that if this product is removed, then there will be more reaction taking place in the forward direction, and we get more yield of this CH3I. So this is about halogenation, and in our next video, I will be discussing more chemical property. So this much for the time being. Good night.